Mark's going to talk to us tonight about Azure Container Apps and how they're going to make our lives easier and mean we don't need Kubernetes anymore. Isn't that right?
Yay!
All right, thanks very much, Mark. Over to you.
Okay, cheers. I was just trying to Simon there. If anybody has any questions as we're going through, then feel free to unmute and just barge in. If not, then if you can't unmute because the kids are hoovering the cat or something like that, then stick it in the chat and Simon will keep an eye on it and read them out to me instead. You'll get a better answer if you're talking to me in person. Right, so yes, I am Mark. I am, for the purposes of this, a developer. People keep trying to tell me that I'm a cloud solution architect, but I want to maintain that I'm a developer. And I'm going to talk to you about Azure Container Apps, which is something fairly new, and I don't think there's really a parallel to it on any of the other clouds. So, so hopefully will be of some sort of interest. So I'll be talking about some of the current hosting options for container-based apps. Then I'll be talking about a couple of things called Kida and Dapr, which you may or may not have heard of. Then I'll have a talk about how that all ties together to make Azure Container Apps, and then we'll do a wee demo and walk through at the end as well. So this is the problem we have, and this is actually a real problem. Imagine, for the sake of argument, that my daughter is doing a master's and is going on to be doing a PhD, and she's a theoretical physicist, and all the prior art for the stuff she's working on is a huge pile of Fortran code. Now she's been working on some stuff to work with this Fortran stuff to sort of update it for some things that need to be sort of researched. And in particular, when she goes into the PhD, she's actually going to be continuing on with this, but there's going to be an awful lot more work, needs to be, sort of processing needs to be done. So this is the way that she could go about it, is to have a front-end website that she builds in something that's not Fortran. In my case, I've done it in .NET because I'm mostly a .NET developer, even though the thing I've just been coding over the weekend has been Node. But imagine that you have that website talking to a background worker process, which is written in Fortran, and you want to have that parallelized, so you can fire off a whole load of work, and the Fortran will analyze each of the work packages in parallel and come back with some sort of answer. And also imagine, just for a bit of extra fun, that the website itself isn't going to be used terribly often. So what we'd like it to do is to turn off and not actually run while it's not being used, so that we don't have to pay for any of this while it's not actually doing any of the processing work. So ways we can approach that at the moment. I'm doing this with a bit of an Azure hat on, but so tell me if your favorite cloud does it better than this. But the first obvious option there is serverless, at least for the background worker processes. Now, the problem with serverless there is that, as far as I know, there are no serverless frameworks which support Fortran. They're kind of tied down to some specific frameworks. Also, you have to use specific coding patterns, so you have to deal with it the way that serverless code is expecting it. So it's a little bit tricky to lift stuff that you've written for for working non-serverless and shift it into a serverless mindset. And the other thing serverless can't do is to host the website side of the things. And of course, it's locked into whatever cloud you're running your serverless on for the most part. So whether you're using Lambdas or Google Cloud Functions or Azure Functions, then once you're coding for that platform, you're kind of locked in. So a couple of other options. If you're on Amazon, you can use App Runner, or if you're on GCP, you can use Cloud Run, and those are essentially easier container runners. Now, the problem about these is that they only scale on HTTP traffic, which is okay for some things, but if you have a whole pile of work coming in, then you can still drown them. So if you're building a proper event-based microservices application, you're going to want to have RabbitMQ or something in there so that you can, so that one service throws the work the work that it needs done into the queue, and then the serverless functions can pick up the messages off that queue and processes them without having to get drowned by a whole load of HTTP traffic from some sort of translation layer. App Runner also won't let you scale to 0, so you've got to have at least one of your containers live all the time and paying for it. And at the end of the day, you're still kind of locked into the platform there. So serverless won't work, and you can't, so it's not so good on one of these easier app hosting options. You end up going for the fun option, which is Kubernetes. And I love this slide because it nicely encapsulates why I don't want to use Kubernetes. You've got that whole big pile down there at the bottom of just people who will help to train you in Kubernetes and help you when your Kubernetes goes wrong, and generally sort of make money out of the fact that it's very difficult to do Kubernetes by yourself. And of course, you've got all these other options of ways to do things, and it just, I'm a developer. It just goes way over my head, all this stuff. But you do have this section in the top corner there called Serverless, and if you zoom in really close, you might see a couple of things in there called Kida and Dapr to help you do serverless on Kubernetes. So if we have a look at what those do. Kida, first of all, is the Kubernetes event-driven autoscaler. And what that will do is it will hook into the HPA, the horizontal pod autoscaler, and allow you to scale your pods in and out, your containers. For those of you who don't know much about Kubernetes, a pod is essentially a container with a few other bits running next to it. But by default, it scales based on how much memory and CPU you're using. What Kida does is it allows you to hook in a whole load of other metrics to that. So specifically, in the case that we're looking at, if we were looking at RabbitMQ or some other service bus message queue, then it can look at the size of that queue, and based on the amount of work that's in there, can scale up, without having to wait for your pods to die under the weight of some sort of HTTP traffic, or to get too stressed and have to start scaling out after the event. It can see preemptively how much work is there and scale you up at the point at which you need it. The other thing it can do, which the horizontal pod autoscaler doesn't do by default, is to actually scale you down to 0. So if you've got your message queue and there's no work in it, it will actually scale your containers right away. It will also do HTTP, and it will also scale your HTTP down to 0. So if you've got your ASP.NET website, for example, and the thing that we're looking at, then it will also scale that down to 0 if nobody's hitting it with HTTP. Any questions in so far, Simon? Or?
Oh, no questions. I have one though.
Yep.
So the horizontal pod autoscaler can be configured to use external, or configured to use other metrics. Is this a better way of doing that?
It's just it's a way of doing that. It sort of neatly packages up the metric, sort of some useful metrics specifically for the serverless scenarios. So you can see there on the slide the various things that it looks at. But it's just a nice, easy, packageable way of saying, okay, I've got my GCP pub sub queue, or I've got something going on in Mongo, sort of a collection in Mongo and container in Mongo, and it gives you a nice, easy declarative way of saying scale this from 0 to whatever, and it kind of it's actually based on what they use in Azure Functions behind the hood. So it's designed to be able to sort of preemptively and configurably scale your stuff up and down based on how much your metrics change, and how much larger or smaller your queue is becoming. So specifically designed for that sort of serverless scenario. Yeah, so that deals with the scaling side of things on the Kubernetes. The other useful thing here, and this comes in particularly useful when we're dealing with something like Fortran, is Dapr, which just means the distributed application runtime, and has a nice little Dapr hat on its logo. And what this is, it's kind of a sidecar, but it doesn't have to be a something sidecar in a pod. It's just a process, just an executable. So if you're running it in local dev, you can just run it on your local machine next to your own code. And what it does is it sits there and it waits either for you to call it using an HTTP or gRPC call, or vice versa. If it's got something to tell you, it will call into you via HTTP or gRPC. So it's got SDKs for your code for a number of the well-known frameworks, Go and Python and Java there. But because at the end of the day, that's sitting on top of just plain old HTTP, you can use it with anything, including Fortran, and anything which has any concept of HTTP at all, which Fortran even doesn't, as we'll go into later, but you can hack around it. But it provides a whole load of useful functions for distributed microservice applications. So you can see there some of the things it does. It'll allow you to do service-to-service invocation, so kind of a bit like a service mesh. But it also allows you to plug in a whole load of other things. So it knows most of the state stores. So if you want to do distributed state management, you can tell Dapr, please save state or get state in my state management store. And then again, you declaratively tell Dapr that your state store is Redis or Mongo or whatever you want it to be. And similarly, you can configure lots of different pub/sub mechanisms and bindings and triggers. So I think there's a Twilio SMS trigger and things like that that it will watch for you and make an HTTP call to your code when there's an SMS comes in. It can help you build out an actor model, and because it's sitting there in between everything, of course, it allows you to do observability, and then it's got secrets and whatever the other one is, and you can build your own extensions on for stuff that you've got which they don't support yet. And because it's just a that very simple sidecar-ish type thing, you can run it on anything you want. Stick two processors in your Raspberry Pi and do it like that if you want, or you can run it on Kubernetes in whatever cloud or wherever. So that gives you a microservice framework thing. So when you've got all your containers, then it makes it easy for those to work together. So I just put a quick slide together there on things it does. So you have 13 pub/sub stores, 39 triggers and bindings, 9 different places to store secrets, and lots of other things. And rather than you having to hook up hook up directly to Redis using the Redis SDK for whatever you're using, it will do that for you, and it will handle retries and all that sort of stuff for you. So you don't have to do that. You can just tell it how many retries you want to have before you have an exception or whatever. Okay, so we have Kubernetes, we have Kida for scaling, and we have Dapr for communication between your container and other containers and other things. And this is where Azure Container Apps comes in. So basically what Azure Container Apps is, it takes Azure Kubernetes, has Dapr and Kida already in there, has Envoy in there as well, for all the good networking and whatever stuff that Envoy is doing. But what it specifically does is it takes out all the complexity. So it only gives, it doesn't give you the full Kubernetes YAML and all that sort of stuff. It just gives you enough to do what you need to do to run sort of the 90% case of what you're going to be doing with containers and microservices and containers running together, even a single container. It just makes it a lot easier and simpler to set this sort of thing up. So you've got your simple configuration there. So you don't have to deal with all your deal with configuring ingresses and all that sort of stuff. Deciding what you're going to plug in there. You just deal with purely the stuff that you need to set up for your application. So the stores it's talking to, how the microservices talk to each other. Everything else is kind of done for you in an opinionated way. It'll work with any container. It has proper serverless consumption pricing. Like I say, it will scale to 0 if you want, if you're not using anything. But if you want to keep the container warm, it actually has idle pricing. So you will pay less when it's not being used, even if it's there and waiting, than you will if it's actually busy. So I think it's like 1/10 of the price when it's not busy. And because it's actually built on Kubernetes, it's nice and easy to actually just take this and say, okay, so at some point, if you decide that you need to do something that container apps can't do, but the Kubernetes can, then you can kind of eject from container apps and pop into Kubernetes, and it will all work pretty much the same. I'm working on a little project to actually automate that, but from what I've seen from the container apps team, they're talking about, it's only in preview at the moment, but they're talking about actually having it so that you can move either way. So it will attempt to take a Kubernetes system which doesn't need to be complex and move it into container apps, but vice versa, a container app system which is needs to be more complex can automatically migrate out to Kubernetes. Okay, any questions there before I move on to the demo a bit?
Yeah.
No, okay. Right, so I'm going to do a demo here. So that's basically on the left-hand side there is the containers like I was talking about at the start. So I'm going to have a .NET API with website. I'm going to have excuse me, have that running sort of on or off. That's going to send messages to service to a service bus in Azure. Those messages will then trigger my serverless Fortran workers. They will maintain shared state in Redis in Azure, and as they're working away, then they will use service-to-service invocation to call back to the initial website and just tell it how they're getting on. One thing, by the way, that container apps can't do yet, it can't host a container that doesn't talk via HTTP. So what I would like to do at some point when they do get TCP working is to actually, rather than using Azure Redis, I hope the managed Azure Redis is to actually just fire in the Redis container into the container app and use that as an extra thing, so that it's all fully portable. But for now, I'm just talking out to Azure services instead. Right, let's see if I can find out how we will. Let's yeah, here we are. Okay, so I'll just quickly show you how the code works here, just so you can see how Dapr hangs into this. So this is my website. So this is a .NET website here. So I'm using I pulled in the Dapr SDK. I've got one thing here which just sends out a pile of messages. So I've got a send worker messages API, and it uses this publish event method, which is just basically saying publish to a pub sub thing. But we don't care what it is. We're just saying it's the one called Dapr pub sub which we configured declaratively, which we'll see shortly, and using the name of the queue and then the message for reasons we're just going to send it a dummy message there. And then there's a couple of wee APIs down there for the front end to use to get the current value of this throughput, which will be updated by the worker app. There's also in there a little index.html file, which really just fires messages to the message pump, and we can turn that on and off, and it will display the throughput as we're going along. And then the fun bit is the Fortran worker here. So Fortran does not have an HTTP stack. It can't, it can't consume HTTP. It can't do an HTTP call. But through the wonders of Apache and CGI, we can actually trigger it anyway, just as a CGI executable. So we can make this Fortran program, and what it will do is it will read, we can read in the body, which again, we're going to ignore because, sort of parsing JSON at this stage would be making more complicated than we actually care about. We can then shell out to curl. So that's how we talk to our Redis. We curl out to Dapr and say that we want to send it into the ACA demo state. I'm going to call it counter 2. I forget why I called it counter 2, probably because it was code that wasn't working in counter 1. So we call that out. We do our complicated calculations. And then again, we curl out with saying we're going to set counter 2 to this value, and we send that back out to Dapr. So we've read something from Redis, we've manipulated it, we've written it back out to Redis, and then we're going to use this invoke thing for the service to service, and that will call through to something on our web app service, the API called throughput. So with a little bit of jiggery pokery there, we've got a Fortran app that will talk to Redis and talk to another container elsewhere in our container app. Hopefully all makes sense. And then this is the DevOpsy bit, since we are a DevOps thing. So this is Bicep, which is the name, which is the excuse me, Azure resource deployment thing. So I'm pretty sure that Terraform also works with container apps. So is there something in the chat there? Or?
Yeah, there was a question about on what point at what level of complexity can you get to an Azure Container Apps before you would move to Kubernetes? So I don't know whether you want to tackle that now or kind of at the next.
Yeah, I mean, at the moment, like I say, it's preview, so it's fairly simple. If everything has to talk HTTP. They've only just put in health endpoints, but they are working on things like that. At the moment, for instance, if you had something that required a GPU, and so you needed to have, your set of taints and whatever they are in Kubernetes, say, this thing must run on some, run on the node with a GPU. That sort of thing's not there yet. So they may put that in at some point, but at the moment it's all fairly simple. Sort of run a container that runs HTTP code and uses fairly standard event-driven serverless type stuff. So there are things like that, and also at the moment, you're tied into using the Azure and observability stuff. So if you want to use, if you like Grafana and Prometheus, at the moment you can't go in and hook something like that in. So you have to use the Azure stuff for that. Having said which, Azure have just sort of worked with, done a thing with Grafana Labs, so that they've now got managed Grafana. So I wouldn't be at all surprised if Grafana does crop up in this at some point as an option. But probably, again, somewhat simplified, so you'll just be Grafana or Azure Insights, Azure Monitor. We're in a movable feast here, so what I say now probably won't be true at release time, but there'll always be some things that you want to do in Kubernetes that sort of don't work in this, but they will hopefully be, well, we're hitting 90% at the moment. Hopefully, eventually they'll hit 99%.
Thank you.
Right, so this is, as I say, a bicep template. Same thing can be done with Terraform, I believe. So there's some input parameters and variables, and then we're creating an Azure Container Registry there, which is where we're going to stick our container images. We're creating a service bus queue for the messages, and we're creating a Redis thing there. As I as alluded to there, we create a log analytics workspace for the container app. And then here's the, down here, so we start with the actual container app bit. So here we're setting up the container app environment. So that's the overall thing that you're going to stick your container apps inside. And as you can see, it's actually Kubernetes, by any other name. But that's all we need to do to actually set up our environment. There's literally just telling it that where its log analytics is. Then within that, we create our web app. So usual sort of thing, we tell it, what our container images is. So using a variable there called ACR server, which is the one, the container registry created earlier, but could be Docker or wherever, and a couple of environment variables that we're passing through, so that so it knows what to tell us. so the code knows what to tell Dapr. Then we've got a nice simple scale rule that has said here that says we're going to scale between 0 and 1, and we're using an HTTP scale rule. Now I've just left that, it doesn't really matter for 0 to 1, but that's the sort of thing where we can say, if we end up backing up with 100 requests that haven't been serviced, that's the point at which you want to start scaling out to more replicas. So if you were scaling between 0 and 10, then that would be how it would work out how to scale it. So that's the key to configuration for that. And then here's the Dapr configuration. So we're telling it Dapr what port our app is going to listen on for anything that comes in from Dapr. And then here we're saying that we're using a Azure Service Bus provider here, and this is where this is the name of the address of the connection string for that, which we've got down here in the secrets section. And this is just telling us for our container registry what credentials we should use to it. Because it's a web app, we're going to tell it to expose port 80 out through the ingress, so it becomes SSL on the far end, but port 80 is what we're going to let people come into from the outside. Little bit of stuff here. What we're saying there is that for the case of this demo, we always just use the latest revision of the container that we posted up, and everything goes to that. But what you can do is it's got the you can have multiple revisions active at any one time. And in theory, if you want to, you can, rather than having 100 wait for one of them and 0 for the rest, you can have 50-50 for whatever. So you can do your A/B testing and all that sort of good stuff between the old revision and the new revision if you want. So that's all we need to do for the web app. And then the worker app is not significantly more complicated. Same idea there. As a container, we haven't, because it's Fortran, I've not bothered sending it any variables. Again, here we're scaling between 0 and 10. In this case, we're using an Azure Service Bus called queue scaling. So we're just telling it what the name of the topic is and what the name of the subscription on that topic is. Same idea of what the connection string is. And then there's a tiny bit more down here. So we're configuring Service Bus now, because this is actually coming in to us, rather than us going out. This name actually becomes important. What that's going to do is to go in to via HTTP to our service /countering, and then in Apache I'd map that through to /CGI bin/countering. That's just a convention. You can actually configure it more than that if you want to, but no particular reason here. And here's Redis, so the same sort of idea. Just host name and credentials there, and our secrets. And because this, we're not exposing this to the outside world, we don't need the ingress thing going on there. And down here, that's just for purposes that tells us what domain, so what the address of the web app is, so we can see that from the output without necessarily going to the portal. That's one thing they don't have at the moment. They haven't put in custom domains just yet, but I would imagine that will be in before it goes into preview. If it comes out of preview. There's another one in the chat there. I think we've got a little red one lobbing at me there.
Yeah, so since Kata monitors your workload for scaling, do you get a dashboard or visual or even just data on the workload for free too? Or is the monitor data under the bonnet only?
Um, at the moment, the Kida stuff isn't exposed. Dapr logs out all its stuff. So yeah, basically, yeah, all the container logs are available to you at the moment through Azure Monitor and Log Analytics. Dapr certainly logs out everything it's doing, so you can get a lot of logs out of that. Kida, I think you can see, I think, when it's scaling up and down, but it doesn't tell you that much about why, not that I've noticed. That's not to say that they won't add that in at some point. Yeah, it's just an open source project, so I could probably go and have a look in the code to find out. But at the moment, you can't see that. What they don't have, which would be nice and would make my demo a lot nicer, would be some sort of nice little graph to say this is how many instances of each of your services are running. But again, we're not there yet. They've only had this out for a month or two at this stage, so at least to the public. So catching up on the fine tuning and that sort of stuff. That answer the question.
Thank you.
Right. So yeah, that's basically it. So this deploys out a container app. That's fairly simple setup. If we don't have all these curly braces, because of bicep, it would look even neater. But we have that thing I was talking about at the start of being able to host a website, which will scale down to 0, being able to host a serverless backend, being able to sort of do that all serverlessly and simply. Another chat in there.
Just confirming that you answered the question.
Okay. Okay. And just as a final bit, I'll just show you what that looks like. So I'm not going to actually bother deploying it because we don't want to sit here and doing the usual thumb twiddling while it deploys anything out. But here's one I made earlier. So yeah, this is what Azure calls a resource group, or sort of a folder, whatever you want to call it, for all the resources. So you can see it's created a container app environment. It's got the 2 container apps as well, and it's got the log analytics there, and then it's got the service bus and the Redis that we're using separately. So, and I can drill down into these and see. There's really not a lot to a container app environment. There's no complexity in there at all. The only, all this stuff here is standard Azure stuff, automation. So the only thing that is in there that's specific to a container app environment is this called apps, and that just lists our apps. And if we go into something like the web app here, then you can see there's a little more stuff in here. So we've got the revision management there. So moment, it should show us that we've got one revision and it's getting all the traffic. But if we were doing it the other way, then it would show us, waking. Yeah, so we've got one, that's provisioned and is getting, active and getting all the traffic. But, we could have more of those with different percentages of traffic. It's got we can have a quick look at our secrets. They're just Kubernetes secrets, so of course you can unbase 60 for them if you really want to. And you've got ingress here. So at the moment this is a public one with ingress enabled, but we could say that we got to talk to people, but only other services within the app environment, and then we configure that. So this is all the stuff that we had in the bicep template, but it's just so you can see what's going on there and what it actually looks like. You've got here that little thing. So if I start sending messages, then you'll see that starts to fire up, going through the Fortran and coming back out. So that's just counting how quickly we're going through. If I stop that, it will carry on processing messages briefly and then stop again. I will work on more impressive one, or use the graphs when they come along to show things scaling up and down. But you just kind of have to believe that for now. Any questions on the demo before I switch back to the slides?
None in the chat.
Okay, so that's pretty much it. There we go. So yeah, so basically, like I said, we're container apps, based on containerized apps that I've worked on myself. It kind of hits the 90% case of nothing too complicated, but complicated enough to do something interesting. It is Kubernetes under the hood, so you get all the Kubernetes stuff going on, but hidden from you until you need it. And it's a lot cheaper. You don't have to pay for it when you're not using it. You don't have to have massive great nodes. I don't know exactly what they're using behind it. I think at the moment they're using normal nodes, but they could, in theory, they could be using Fargate, like AWS. There's a thing called Azure Container Instances, basically, which allows you to just fire up individual containers without having to have a specific node. It uses the virtual kubelet thing in Kubernetes to fire up individual containers. But it means that there's no node sitting there when you're not using it. It's nice and easy to DevOps it up. That one file we saw, that one template, was all you needed, and like I said, would probably look even neater in Terraform. And you're not locked in, so you can shove it out to Kubernetes and go and run it in Kubernetes on premises or in GCP or AWS or Alibaba Cloud or something like that. That's it. So I've set up a couple of things on my URL shortener if anybody wants to have a look into it a bit more, or just to look into Kida and Dapr and stick them into your own Kubernetes for that matter. And that's everything.
Cool. You mentioned there about it being cheaper. In the Bicep, did you have to specify memory and CPU requests, or is that part of the granularity that's lost, or are there sensible defaults?
There is. I mean, for what I'm doing here for a demo, there's no particular need to do that. I'm pretty sure that's a configurable thing, though. Same as in Kubernetes.
Okay. Do feel free to unmute yourselves, people, if you have other questions. I'm going to keep asking because I always take advantage of these to ask my own questions. How did you find working with Bicep? Have you used things like Terraform or Pulumi or dreaded Azure Resource Manager templates in the past?
Yeah, I mean, Bicep is the new version of ARM templates, so it just basically does all the stuff that ARM templates could do, but a lot easier. So you can, if we go back there, it's it just does things like web app.properties.configuration.ingress.fully qualified domain name, which would take you about 7 lines in ARM. And if I'm there's one here, to go and talk to my my own container registry, which I just use for everything, then all I need to do is say existing, and it will go off and get all the references to that for me, so that I can then go and say acr.properties.log and serve and stuff. So yeah, it's quite nice. Squiggly brackets I'm not 100% sold on, but as a C#, sort of a squiggly brackets developer, it doesn't hurt too much. And it does have the advantage of, because it's ARM based, it's a bit like Kubernetes in that it's desired state. So it's not like Terraform where you have to keep a local copy of state. I do like the fact that you can just say this is my desired state, and it will, by and large, just make your environment look like what you've declared in this file.
Okay, good. Yeah, we're in work. We're 90+% Azure, and we use Terraform to manage nearly all of it. But we've been stretching Terraform to its limits. And I don't know whether Bicep is a suitable alternative, or like Pulumi.
I would say if you're only doing Azure, obviously Bicep's an Azure only thing. But if you're only doing Azure, then yeah, I can't see a reason why you wouldn't use it. except that if you've already got your Terraform, you probably don't want to necessarily translate all your Terraform. But,
True.
but it's very easy to work with.
And what's the feature lag like in terms of here's a new Azure feature and then Bicep supporting it?
It comes, I think it's pretty much when it goes into the CLI, it goes into Bicep as well. At the end of the day, everything has to go into, this is ARM, and ARM is, sort of the single source of truth. So
yeah,
you could have it in there all the time. Now, if you're actually configuring, then I think there might be a couple of advantages to using CLI. I mean, I could have done all this with CLI as well, but they should be pretty much hand in hand. And Terraform, like I say, has been keeping up pretty well as from what I've heard.
Yeah, it does. There's a little bit of lag, but it's pretty good. It's pretty good. If it's not in Terraform, it usually means that that particular service isn't fully baked yet.
Yeah, no, I mean, I think because container apps, I mean, I'm reading between the lines here, but the existing things like app service and Kubernetes, I strongly suspect that container apps will start to become the default app deployment mechanism, even if it's just a single website like you've got on, you would be doing an app service, or serverless thing like you would have been doing with Azure Functions. I suspect that this will become the preferred option for both of those.
Okay.
So, Interesting. I think Terraform, Terraform people are treating this as quite an important thing to look
at. Yeah, Chris in the chat there saying that they're using Bicep and work, and they're liking it a lot. So it has a build step to output ARM templates. When would you? So does Bicep talk directly to the APIs, or do you generate templates from it and then apply them?
It's kind of a DSL over ARM, so it does compile down, it does compile down to actual ARM at the end of the day. It's just that you generally don't have to see that bit.
Okay.
And more things are just taking Bicep in as native rather than having to do that intermediate step. But yes, it's when they first did it, it was literally you just said, okay, please turn this Bicep into ARM, and then do the ARM the way you were doing the ARM thing.
Right. Okay. Cool. Well, thank you very much, Mark. It's been very useful, very informative.
It's kind of a watch this space thing, because it is moving very fast. But like I say, I think if you're in Azure, and even if you're not in Azure, it's going to become quite a big thing. It'd be interesting to see whether App Runner and sort of Cloud Run do actually start to take some notes from this and start to enhance their simple container options.
Yeah, I think it can be very easy to get lost or run away with the complexity that's available to you in Kubernetes. And one of the internal conversations we're continually having is, should we have a more defined platform that does constrain people, instead of letting everybody make their own choices? How do you balance giving people the freedom to get their work done, and then also not giving them the freedom to create a mess, or create 15 different solutions to the same problem, because there's 15 different groups looking at the same problem?
Yeah, I think that's kind of the audience that this is aimed at, is people who would really like to not have to use Kubernetes. They do.
Yes. Cool. All right. Well, if nobody has any other questions, I could sit here and ask awkward questions all night, but I'm sure you have better things to do with your time, everybody.
Depends whether you count United versus Liverpool is a good use of time, really.
I don't, because the ball is the wrong shape in that sport for me. So I'll let those who are interested in that run on. Thank you very much again, Mark. This has been great. Thanks for coming along. And thank you, everybody else, for coming along.
Okay,
This has been recorded, and we'll be posting it as soon as I get an hour to shove it through iMovie and upload it. So thank you very much, everybody.
Okay. Hey, everyone.